Okay, continuing on, we are now going to do section 10.4, which is applications with volume. So I'm just going to go through these two examples with you, and then that's it for the 10.4 notes. So in an effort to minimize costs but keep the same volume, Grip Soda Company wants to change the design of their can from the cylinder shown, so this guy, to a cone with a radius of 4 inches. What would the height of the cone have to be? So you got to think problem solving here, and you always start with whatever you're given. So I am given this information. I'm not sure where that's going to take me at first, and I want you to be okay with the fact you are not going to know where this is going right away. Okay, you just got to think, okay, I'm given this information, I got to work with that to start. Okay, what am I going to do with this? Well, it says I'm going to keep the same volume. So I'm going to find the volume of the cylinder. Again, I'm not sure where that's going to take me, but that's the information that I'm given. Okay, so the volume of the cylinder, of course, I'm going to do the base area and then times the perpendicular height. So we're assuming this is perpendicular as a soda can. All right, so I have 4 pi times 16. So that's going to be 64 pi, and that's inches cubed. So here's a good start, right? Okay, now I'm going to reread the question and see what else I can do with this information. So in an effort to minimize the cost, but keep the same volume, well, that's really important. It has to be the same volume. So whatever volume I get for the cylinder, I'm also going to have that same volume for the cone. Okay, and then the cone is going to have a radius of 4 inches. So what I'm going to do is draw myself a cone, and I know this radius is 4 inches. That's 4. And then I'm going to have a cone here. So it looks something like that. And I'm just fitting it in the picture here. All right, so this volume needs to be the same as that volume. So now I'm going to go to the volume of a cone. Well, I know it has to be 64 pi because they have the same volume. Then what I'm going to do is write out the volume of a cone formula. Now I'm also given the radius is 4, and here I'm looking for a height. All right, volume of a cone. Well, it's very similar to the volume of a cylinder, except you need to have your 1/3 on it. So 1/3 the base area, and then times that perpendicular height. All right, so now I have something to work with where I can figure out that height, which is what I want, right? I'm looking for the height of the cone. All right, so going through this, here I have the pi's that'll cancel. And then after that, I'm going to, you can do this in whatever order you'd like to. So I would probably, this is a 16, I'd probably divide by 16 first. So you could even I'll write it out just to be super clear. So that cancels with that. And then, so here's 4. And now I have 1/3 h is all that's left. So 64 divided by 16 is 4. I copy the 1/3 and then the h. And then I'm going to multiply by 3. And so the height is going to be 12 inches. So this can is actually sort of a weird shape. It's first of all cone. So where do you put the opening to drink out of? You must put it up here at the vertex, and then this would be super tall. And in fact, this one's super tall too. But anyway, the point is that you end up with 12 inches as the height of that cone. Okay, number 5. So I want you to think in those same terms. You are given what information? I'm given that it's a cylinder. I'm given I want to do volume. So find the volume of a cylinder with a height of 10 inches and a total area of 78 pi inches squared. So first thing, if you don't have a picture, I would always draw yourself a picture. So for a cylinder, we're going to do 2 ovals, and then you just connect the outsides like that. And then we're going to label this as 10 inches for the height. Okay, obviously we need to figure out, if I'm going to do volume, I need to figure out the base area in order to figure out the volume. Okay, so how the heck do I do that? Well, the other information you are given, remember you always start with your given information, is that you have a total area, and total area is just like saying surface area. So I'm going to say it as surface area. But the surface area is 78 pi. So I'm going to write that down. Okay, this is everything I've been given. Well, I can go somewhere with this. And again, you're not going to know where it's going to go until you start writing things down. So always write things down. Don't just stare at a blank piece of paper. You need to write things down as you go. So let's think about it. Surface area is 78 pi. All right, so let me write some things down. I have 2 circles, and then I'm going to have that lateral rectangle when you open it up. Okay, so that I can work with, right? So 78 pi, and then I'm going to have 2 pi r squareds, because I don't know the radius. And then this guy is, there's going to be 10 there, and then this is going to be diameter, diameter times pi. Well, I want to keep one variable, so I am going to call this 2r. That's diameter, and then pi, and then times 10. So sorry, I'm kind of cramming that in there. But this is the area of that rectangle. So 2r is the diameter times pi times 10. What that allows me is an equation with only r's. Okay, the solving of this is kind of a nightmare. So I'm not gonna sugarcoat that for you. So let's start simplifying. We have 78 pi. Okay, simplifying this, I'm just going to write it as 2 pi r squared. And then putting stuff together here is 20 and then pi r. So simplifying, let's divide everything by pi. So you need to divide every single piece of the equation by pi, but those will all disappear. You can also divide everything by 2. So what you're going to end up with is, so 78 divided by 2 is what, 39? That 2 goes away, you get r squared, and then divide by 2 here, you get 10r. So now it looks a lot easier once you've simplified everything. But this is a quadratic, so I am going to give you a minute to pause and solve the quadratic. Okay, welcome back. So you should move over that 39 to start. Okay, and then I'll start moving this over here. But you factor. So r, r. So multiples are factors of 39. What do we got? 3 times 13 looks promising. So we have a 3 and a 13. We want a positive 10, so positive 13 and a negative 3. Okay, so final answer, you set those equal to 0, and you get a 3 and a negative 13. In a geometry problem, having a radius of a negative is not going to make sense. So I end up getting a radius of 3. Okay, so I'm going to draw that in my picture. And that's going to be 3 inches. Okay, going back to the original question, it's asking for the volume of this cylinder. Well, once you have the radius, that's pretty easy. So you do the base area times the perpendicular height. And so you get 90 pi and cubic inches. Okay, so those are some problem-solving examples.